Let's look at this problem. If you want to solve it using mesh analysis, you have 3 meshes, I1, 2, 3. 3 meshes. Okay. Then if you want to write equation for I1, the main current is I1. So I1 times what? Times 10 plus 2. Plus 2. I1 times 10 plus 2. Minus. This mesh intersects with the other meshes in what? Intersects with I2 in 2. Intersect with I2 in 2. So it is minus I2 times 2. And intersect with I3 in what? Okay. Don't tell me that it is 6 volt. No. Intersects with I3 in what resistance? What resistor, I mean. Okay. So there's no resistors here. So imagine that you have a resistor and its value is 0. Okay. So it will be minus I3 times 0. So you can write I3 times 0, or you can just neglect it. Okay. So this will be the first equation. But equal what? Equal the source. Do we have a source here? Yes, we have this 6 volt. And 6 volt is positive because it is in the clockwise direction. The 6 volt is moving in this direction, or it is in this direction. Sorry, not moving. It is in this direction. So it is in the clockwise direction of I1. Okay. For mesh number 2, it will be I2 time what? Time 4 plus 2 plus 1. These are the 3 resistors in this mesh. For mesh number 2, you have 4, 2, and 12. Okay. Let me do this. And then after that, I'll use the laser. So again, this mesh here has 3 currents. 4, 2, 3 resistors. 4, 2, and 1. So it is I2 time 4 plus 2 plus 1. Minus the intersection, it makes sense that it is very clear that this mesh intersects with mesh number 1 in 2 ohm. So it is minus I1 time 2, and intersects with mesh number 3 in 1 ohm. So it is minus I3 time 1. Equal what? Equals the source. The source is 8 volt. But 8 volt is negative. Why? Because it is opposite to the clockwise direction. Opposite to the clockwise direction. When you move from this branch, the clockwise direction is from top to bottom, which is opposite to the voltage. For mesh number 3, the main current is I3. I3 time what? Time 5 and 1. So I3 time 5 plus 1. Minus the intersection. Again, this mesh intersects with I1 in nothing here. You don't have resistors here. So you can say I1 times 0. And intersects with mesh number 2 in 1. So you can say minus I2 times 1. Equals the source. Do we have any sources in this mesh? Yes. We have 2 sources. 6 volt and 8 volt. 8 volt is positive, you see. 6 volt is negative. You see, 8 volt is positive and 6 volt is negative. So it will be 8 minus 6. So this will be the solution for this one here, or the 3 equations for this problem. If we want to solve this problem using nodal analysis, then in this case we have to use this one as a reference, and then we'll have V1 and V2 and V3. Then you need to solve it, of course. You have to notice here that V2 and V3 is a supernode. V2 and V3 is a supernode. So you have to make sure, be careful here when you solve it using nodal analysis. So for example, as this node, when you write the equation at node number 1, it is V1 divided by 4 plus V1 minus V2 divided by 2 plus V1 minus V3 divided by 10. So this is the equation equals 0. For the nodal, for V2 and V3, this is a mesh, this is a super node. First, you know that V2 minus V3 is 6 volt. V2 minus V3 is 6 volt. And when you merge these two together, imagine that you merge them together. So now we have these two are one mesh. Okay. Imagine that these two are one mesh. Then now, how many currents out of this mesh? From this side, you have this current and this current. and from this current, from this side, it is this current and this current. So you have 4 currents, and the 4 currents are very easy. The first current here is V2 minus V1 divided by 2. V1 minus V2 minus V1 divided by 2. Second is V2 minus this voltage here, which is 8 volt. This is 8 volt, okay, divided by 1. So it is V2 minus 8 divided by 1. And the next one is this current, for example, here is V3. This one is V3 minus V1 divided by 10. V3 minus V1 divided by 10. And the last one is V3 minus 0 divided by 5. Okay, then this will be the when you apply Kirchhoff current law at the supernode. For these 2 problems, you just need to solve them using mesh analysis. So the main current in the first one is I1. Okay, so it will be I1 times what? Time 20 plus 30. Okay, minus the intersection. Of course, mesh number 1 intersect with mesh number 2 in 30 ohm. Then it will be minus I2 times 30. Equal what? Equals the source. The source is V1. And the V1 is positive because it is in the clockwise direction. Then you go to the next one. Mesh number 2. Mesh number 2. Okay. You have how many resistors? You have 3. 3 resistors. So it is I2 times 30 plus 30 plus 40. 30 plus 30 plus 40. Minus the intersection. Of course, this mesh intersects with I1 in 30 and intersects with I3, mesh number 3 in 40 ohm. So it will be minus 30 I1 times 30 minus I3 times 40. Equal what? Equals the source. You have only one source here, which is V2, and V2 is in the clockwise direction. It is in the clockwise direction, then it is positive. For the last mesh, the main current is I3. I3 times what? Time 40 plus 10, or 10 plus 40. Okay. Minus this mesh number 3 intersects with mesh number 2 in the 40 ohm. So minus I2 times 40 equals the source, which is V3. V3 is in the clockwise direction because the clockwise direction is in this direction here. This is the clockwise direction. So it's look like this, right? So here, of course, it is very clear that it is the same direction like the source. Both are in the same direction. Then it is positive I3. Then now you have the 3 equations in 3 unknowns. Okay, now let us look at this example. For this example, if you want to solve this, you can notice that I3 and I4, there is a current source in between. There's a current source in between. Then now how can we deal with this? If we have a voltage source, you don't have a problem. But if you have a current source, how do you do that? How do you do that? Why? Because you apply Kirchhoff voltage law. Kirchhoff voltage law. Okay, so actually you add voltages. If you look at, for example, any equation like this one, this equation here, what are these terms? Current time resistance, voltage. Current time resistance, voltage. Current time resistance equal what? Equal voltage. Okay, so all voltages because this is Kirchhoff voltage law. But if you have a current source, then in this case you cannot say voltage plus voltage minus voltage equal current. You cannot do that. Okay, so you cannot do that. So if you have a current source in between, then you have to be careful when you use mesh analysis. So let us see some cases for the mesh currents. Okay. For in mesh analysis, remember this. If you have a current source in the outer loop, the loop that's outside, from outside, okay, then this current is the same like the mesh current. That's it. It will be very easy for you to do it like this. So for example, here, look at this one, 50 or 5 ampere. 5 ampere. Okay? It is in the outer loop. Where is the outer loop? If you have problem understanding what's the outer loop, let's make it in green, for example. So this is the outer loop. This is the outer loop. And you see here we have this 5 ampere in the outer loop. Okay? So this means that this I1 equal to 5 ampere. I1 equal to 5 ampere. But you have to consider the direction. Is it positive or negative? Depending on the direction. It's clear that I1 and 5 ampere are in the same direction. Because you notice here, if you look at this, this is a this is a 5 ampere. 5 ampere is here. Okay. And where's I1? I1 is in this direction, clockwise, like this. Okay, so this is a clockwise direction. So now what I'm caring about this branch here. You see, both of them are in the same direction. Then I1 equal 5 ampere. I1 equal 5 ampere. Same for this example. If you look at this example here, the second one, the bottom, you will find this 3 milli is outside because this is a branch, outside branch. Here it is, this one. Okay. So it is very clear that this 3 milliampere is equal to I1, but in amplitude. Is it in the same direction? Yes, it is in the same direction. If you can't notice that, let's see. In general, the circuit looks like this. It has two meshes. And mesh number 1 is clockwise like this. I1, sorry. I1 is here, like this. Look like this. This is I1. Now, where is the source? The source is here. It's in this direction. This is the 3 milliampere. And it is the same direction like the mesh current. Same direction. So I1 equals 3 milliampere.